you should expect to see two different answers here, two x values. Okay. I think this is a little bit easier. This is like solving linear equations, except we've got a squared there. That's all. Okay, and we have a way to deal with the squared, which I think we may have even already seen. Okay, we're just adding a few more things. So, methods to solving quadratics. Okay, this is the same three steps from yesterday, or same three processes, right? We're gonna have the square root method. I'll write in black here. Okay, now in order to use the square root method, remember earlier with my parabola that I drew on the board, there's a particular point of interest that we're going to deal with in Unit 4 called the vertex. So naturally, if there's an entire unit for it, there's probably an entire, like, there's a specific way to write a parabola in vertex form, okay? So there's a whole equation designated for vertex form, and it looks like this. You've already seen it because we wrote it yesterday, but y equals ax minus h squared plus k. Okay, those variables don't mean anything to you right now. They will when we do Unit 4. That's not the point of today, okay? The point of today is just you will be given all the information, like a, h, and k will be numbers in today because you don't have anything to stress about. We're just solving, okay? But it has to look like that. Has to look like this in order to use this method is basically the gist of it, okay? Then from there, we had the factoring method, which you should all be experts at, hopefully. Okay, this is like I factor, and then I state x equals this and x equals that. That's lesson 5.1, which we did yesterday, right? The third one, which we'll also do today, this will be actually after break, is the quadratic equation. And I have a little surprise for you in period 2 today. It's a math surprise though, so don't get too excited. Okay, so the factoring method, so these are your three forms from your quadratic sheet that I gave you yesterday. Okay, everybody remember these? Where did I put it? Everybody remember this? All I'm writing down here are the three forms, right? So here's number 2. This is what we just wrote down, factored form. So you can put that in the blank if you wanted. The first one was vertex form. And the third one, for quadratic equation, you needed to look at like standard form. This will be number 3, okay? I'll go back to the sheet here in a sec, but I just want you guys to see. Like, in relation, this is why I was saying that that piece of paper was pretty important yesterday, okay? Because it tells you, here's your 3 forms of a parabola. They all are the same parabola. You could type it into Desmos 3 different ways. You'd get the same graph out, okay? What we spend our time doing in this course is the processes, however you pronounce that, to switch between each of the forms. That's all we're doing, okay? To ultimately produce the graph without the use of Desmos. So that if I give you an equation, you have all of these tools, as we will do them, to graph the thing or answer a particular question. Does that make sense? We spend so much time on this and nobody ever I don't think it's ever really clear as to what the big picture is. This is the big picture, right? If I give you something in vertex form and I ask you a question about something that relates to how far the ball went, that's what we're going to do today. We're going to solve for x to tell me how far the ball went. How far did I throw it? Okay, so I'm going to use my square root method to do that. Okay? Is that okay? So it has to look like, I don't know what number this was now, but y equals a x minus s, x minus t. That's where you're trying to get to. And then for the quadratic equation, this is a standard form, okay? which we've seen that before. Okay. That's like what you guys have done so far, and what your quiz is on today is taking equations that look like this one and switching them into make them look like that. That's factoring, right? The opposite was expansion. Okay, so we're just dancing around between both of these forms, right? Factored form or standard form. That's what we've done so far. Switch back and forth to answer different things. Okay? Is everybody okay? Okay, so let's go down here. When your quadratic is in the vertex form, okay, that's, remember I said we were dealing with this guy today, number 1, okay? It's easiest to solve for the x variable, or whatever variable you're solving for, using this square root method, okay? Okay, so this is some things to remember. Every positive real number has 2 square roots, okay? One is positive, and the other one's negative. That's going to come into play after, okay? So for example, if I were to actually, and nobody's ever shown you this before, but if I square root this, like say 49, everybody thinks, oh, the square root is just 7. What it's saying is that it's also equal to -7. For the reason of, like, anytime you have I've never really actually put a lot of thought into why that is the case. But if you think about like what a square root is in terms of name and what it is like relative to its like opposite of square rooting something is squaring. Well, we've come to learn in the last few days that if I write x squared anywhere on my page, you should expect 2 x values. Okay, so if I square root something, I should still expect to see 2 answers because it's just the opposite of squaring. Okay? Is that okay? Some of these things you just got to take at face value for now, and then we'll start to like really put it together tomorrow. Okay? And I promise, like, this is just a lot of words. Like, the process isn't that bad. Okay? I gave you 4 homework questions. I think that's all you need, really, to be honest with you, for this lesson. Okay? Okay, so your calculator always finds the principal one or the positive, right? That's when you type it in. Okay. So here's a question that you might see, okay? And if I were to pull up Desmos, I'll draw it on the board because sometimes when I start doing multiple things, it goes messy. I don't know if I could pull it up actually. If I draw something like this, right? Like if I drew a parabola, something like, let's say we drew the one from yesterday. And it crosses at these 2 points, right? This is x and y. What is the y value at these 2 points? Yeah, Lucas, yeah? 0. Does everybody see that there's 0? Like if I wrote down what the coordinal points of these were, it would be like an x value 1, but you know the y value is going to be 0, right? And then on this one, it'd be like a second x value and 0. The y value, it doesn't have any height vertically, right? So the y value is 0. Does that make sense? So before you get too carried away here, this thing here, this equation, should actually be written as y equals -5 times x minus 4 squared plus 25. What they've done right off the top here is they've said, okay, I'm going to try and solve for x. I'm going to pick the kind of easiest place to do that, and I'm going to eliminate one of the variables. by choosing like the points where y equals 0. So if y equals 0, they say that here. They make 0 equals. Now I'm able to solve for those 2 points that satisfy where this graph crosses at 0. Right? Is that okay? Without getting too crazy here? Okay, it's just like, if I'm interested in x, I'm going to plug in y equals 0 so that I can solve for it, because that's where it's going to cross the x-axis when y equals 0. Okay, so that's what's happened. Now you have something that looks a little bit nicer. And so the game here, all that you're going to do, or for the first step, you just want to get the x minus 4 piece isolated. You can kind of treat that for like a variable for the moment. Okay? I just want to get it by itself. So, how do you do that? Well, I can subtract 25 from both sides. Let's start there. So negative 25 is equal to negative 5 times x minus 4 squared. I'm almost there. Remember, I want to just get this by itself.
You want it including the square?
For now, yeah. I'm being very, you probably wouldn't normally, well, yeah, you're going to do it this normally, like labored intensive, but I'm laying it step by step here. Okay. Now again, how would I get the x minus 4 squared by itself? This is like the order in which I'm doing things, right? So I always kind of like, I take the plus 25, I move it over, whatever number's on the end. I move it to the other side. Second step is, okay, I still have this minus 5 attached to the piece that I want to get by itself. So if I just decide to go, okay, well, I'm going to divide both sides by negative 5. Now they cancel out. So you're left with 25 divided by negative 5. It's going to be 5 equals x minus 4 squared. Now I have the piece that I was after by itself. This is like this one is to move the 25 over. Step 2 is to untie by division whatever number's in front of the brackets. Okay? The second step is now we can deal with the square root on the other side. Okay? Or sorry, the squared. Okay? To deal with that, you're just going to do the opposite of squaring, which we said earlier was square rooting. Right? I could prove that to you by saying, okay, well, if I said 6 squared equals 36, what's the square root of 36? They're opposites. Okay, just to prove it to you numerically so you believe me. Okay, so when I'm about to do what I'm doing, and I suppose it could be plus minus. Can I show you one other thing before we go any further? Without getting too crazy, okay? This is just adds a layer to the why it's a plus minus. It should in theory be plus minus square root 6. Here's why. What's negative 6 squared? What's 6 squared? 2 negatives make a positive. 2 positives make a positive. That's why you must incorporate the fact that both of them work. Because when you square them, the sign's irrelevant because you've squared it. Does that add an extra layer for you of thinking I'm not crazy? That's plus minus. That's 2 existence. Okay? So what you're going to do now is you have the equation. I'm just going to rewrite the equation here. 5 equals x minus 4 squared. Okay? So from there, I can go square root both sides, but when I do that, you have to write the plus minus on the left, right? For the reason of right here, both the negative and the positive satisfy it. Yeah, Retta?
Is that the same reason that they write it in the quadratic formula?
Yeah, that's exactly why. Yeah, we'll learn that. That's that. Well, it's just laying, like, I'm doing a little bit more talking than, like, maybe what's accounted for here today, but what I guess what I'm trying to address is, like, to eliminate some of the questions that I think you guys are going to have with, like, why is there a plus minus, right? That would be the major one. But then when we get to this afternoon, like, why is there a plus minus in the quadratic equation? This is why. Okay. Okay. So then, the square root kind of cancels out that squared that's on the x minus 4. So I'm going to still keep the plus minus root 5 thing. But then, now on the right side, I only have an x minus 4. Okay, so you're just going to solve for x now. Now you've untied the entire equation to get to x. Remember, that's what we're after, right? We're just trying to get x by itself like any other equation that we solved. This is just kind of the grade 10 version of solving equations, that's all. It's still just solving for x. Just throwing a few more things in there to confuse you. That's all, right? So how do I get x by itself? I just add 4 to both sides. So, don't forget about the plus minus though. You're going to get 4 plus minus square root 5. And that should equal 0, right? Still.
Hey, wouldn't you get 4 plus minus square root of 5?
Yeah. Yeah, just one sec. Okay, so this is like a short form way of saying that both of those are happening at the same time. Both of them are valid. Right? So in theory, or sorry, it's not 0, sorry, it's x. Silly me. Okay? So in reality, you're gonna write 2 things on your page, and when you go to solve all of these questions, right, you're always gonna write this. You're gonna have one that's like dealing with the positive, so it's x equals 4 plus root 5. And you're going to have x equals 4 minus root 5. Okay? If you guys are running out of room, sorry, I get carried away sometimes. It can go down here too, okay? So there's 2 possible answers. This little portion here, I think, goes down in the bottom box, sorry. Is that okay? Okay, it's a little bit faster than like it's what we call solving directly for x instead of expanding so that you can use quadratic equation later, which we'll see. Okay, it's like a little shortcut. It saves you some time. Yeah.
You have to expand to be able to use the quadratic.
Yeah, that's what I mean. It's more work for you. This is just another way to solve. Retta has a little bit more foresight. Like when we see this afternoon, I'll revisit this after lunch or like in last period today. In order to use quadratic equation number 3, it has to look like this. Right? So it's more work for you. They both do the same thing. They're going to both spit out 2x values for questions that are a little bit tougher. But the issue with when it's written in the way that it is with this question here, you would have to expand it to make it look like this equation first, then use quadratic. It's more work. This is what we mean by just solving directly for x. Okay? Like a linear equation. Is that okay? So, the good quality of this method is that it's fast, quick, and easy. Again, I'll put the word easy in quotation marks, because that's a little bit of a subjective term for everybody. Okay? The bad quality of this method is that it's only good for when the parabola, all right, quadratic. Okay, it's only good for when it's in vertex form. Okay? Are we okay? So we'll just, this is all this is now. We're just going to solve some questions. Okay, and the last one will be like kind of a little word problem, and then we'll be able to answer something, okay? I'll try and provide context to what it means, okay? So I'll just start slow, and then maybe by the end I'll start ramping it up. And like honestly, I give you 4 homework questions. Like if you could do those 4 homework questions, I'm not going to make them harder than those 4 homework questions on the test. Right? Is that okay?
Is this something on the test tomorrow?
Nope. The test tomorrow is only factoring. That's it. Okay? You don't even have to tell me x equals on the test tomorrow. You just say factor. I'm just going to say factor and simplify tomorrow. Okay? Don't even worry about 5.1 yet. Okay? That'll be the next test. Okay? So don't write x equals this and x equals that on your test tomorrow. You don't need to do that. You can if you want. I'm just not going to mark it. Okay? You're just going to factor. That's it. Just those 6 lessons, 3.1 to 3.6. Okay. So let's just practice. This is the same thing. Okay? Remember what I'm trying to do. Step 1 was just take the -8, move it over. So I get, when I bring it over, it becomes +8, right? I'm going to add 8 to both sides. So 8 equals 1/2 x minus 1 squared. Okay? Then the other thing is I don't think I'll, depends on how I feel of whether or not I give you some nice questions. You'll see what I mean by nice questions versus some not so nice questions, okay? Like one of these probably won't work as nice. Okay? Now what? Remember, this is like when I multiply something, like a fraction by something, this is in theory divided by 2, is it not? Is anybody freaking out right now? Or is that completely brand new to anybody? Okay, that's fine. So this is 1/2, right? And we're multiplying it by something else that could be treated like a fraction if I put it over 1, right? So how do we multiply by fractions by fractions? It's 1 times the top, right? Top times top, bottom times bottom. So in theory, this should turn into 8 equals x minus 1, because 1 times that piece is just itself, but 2 times 1 in the bottom turns into 2. That's all that's happened. Okay, so when you see a fraction out front like that, you can just, you don't have to show me that to switch. Like you could just write it like that. It's fine. Okay, the reason why I do that is because now it's a little bit easier to tell everybody that if I to move the 2, I just have to multiply both sides by 2. Everybody a little bit more familiar with that than like I have a fraction of 1/2 and multiply by 2. Not everybody gets it that way. Okay, so you just multiply both sides by 2. That knocks the 2's out on the right side. So in theory, you get 16 is equal to x minus 1 squared. At which point, remember, I'm just trying to get at that x. Right from the very beginning, I'm trying to get at the x. I'm just doing steps to get there. That's all. Right? So now I can square root both sides, plus minus. Right? So I get plus minus 4 is equal to x minus 1. Yeah, Coco?
So wait, what is like the plus minus in the square root here? Like why do you put that?
For this reason up here, you remember I showed you you always have to put the plus minus because if I square a negative, it turns positive, right? If I square a positive, it's also positive. So both of those answers satisfy the quadratic.
So then why do we leave it like plus, yeah, plus negative?
I'm not done yet, but so we're gonna keep going, right? So like this question here, right? You see how I kind of left it, well, you see in a sec here. That's a bit messy because I crunched that, or crunch that in there. Okay, all I'm after is getting the x. So now I'm just gonna add 1 to both sides. So I get 1 plus minus 4 equals x. Now your final answers, you're gonna tell me what x is equal to. You have two answers. One deals with the plus sign. The other one deals with the negative. So you're gonna have 1 plus 4 equals x. 1 minus 4 equals x. So x equals 5, x equals negative 3.
How did you add 1 to negative 1?
Say that again, sir?
So why did you add, sorry, why did you add 1 to the negative 1?
Oh, yeah, okay, so I'll reword this. It's like, all I'm trying to do is get x by itself, right?
Yeah.
So I'm gonna take this and I'm gonna move it to the other side. So the opposite, or the other way of saying that, the opposite of subtracting 1 is just adding 1.
Oh, so you're just moving.
You're just trying to isolate for x, that's all.
Oh.
Just like a line.
Okay.
It's like we're at that stage now where like that looks like a line or a linear equation because you got rid of the x squared, the squared term anyway. Is that okay?
Yeah.
Just isolation. It's all stuff you guys know how to do. Just looks a little bit different, that's all. Okay, everybody okay with those two answers? We could confirm that those actually work by plugging them in there. Right. Let's do the next one. I'm gonna add 6 to both sides, right? So I get 6 equals negative 2 times x minus 3 squared. Okay, then I'm going to divide both sides by negative 2.
You don't really have space on our page.
I know, it's horrible. I tried my best to give you more room. I could just write this one. You guys can copy it down later. I'll post it. If you want to write it on a separate piece of paper or something. Oh, true. Yeah, I guess sorry. When I make these things, I guess like when I visualize, like when I see them in my iPad, like I don't have a page break. That's my bad. I have lots of room. You guys don't. I did think about this. That's where you have to write it. That's my bad. I'll have to fix that. Okay, I can just do this. You guys can copy it on a piece of paper later. It's okay. Don't worry about copying this one. Okay, there should be more room on the bottom ones here. So I divide both sides by negative, what did I say? Divide both sides by negative 2, right? That knocks those out, and you're going to get 6 divided by negative 2 will be negative 3 is equal to x minus 3 squared. What's the problem with this question? This will be a good one to watch, yeah.
When you square root negative 3, you can't have plus minus.
Okay.
Because you can't, like, doing, like, 3 times 3 or something would equal another positive.
Okay, good. So you fundamentally broke down what a square root does, right? So the fact of the matter is, just as a general rule, you cannot take the square root of a negative number. It just spits out an error in your calculator if you try and do it. So this means something special, which we'll discuss tomorrow as well. Okay? If you get an error, like we'll try this after, I'll plot this graph for you, and you tell me what's interesting about it. Okay? We'll come back to this one. Okay, but the rule of thumb here is that you can't square root and negative. So I suppose the answer to this question, without giving it away, is what the graph looks like, is that you don't have any solutions for questions like this. There are no values of x that satisfy that equation, which is kind of interesting to think about. I'm going to leave you to think about that as to like how that could be, and then I'll show you, once we get through this, I'll pull it up on Desmos and it'll make sense. Okay, and it means it'll make even more sense when we do the lesson specifically on finding the number of solutions for a quadratic. That's like 5, 5 or something, 5, 6. Okay, is that okay? Big rule, no square rooting negative numbers, not allowed. Okay. What about the next one? You guys should have lots of room here. Okay, we'll try to get through these, and then I'll give you, should have lots of time to get some questions on actually. Okay. Okay, I'm just going to take the negative 90, I'm going to move it over. So it's x minus 5 squared is equal to 90. And then you can square root both sides. Plus minus. Okay, so I get x minus 5 is equal to plus minus root 90. I would say your future self, your future math teachers, your future science teachers would thank yourself right now to not type root 90 unless you get an exact number. Don't type root 90 into your calculator. You will thank yourself later. This really honestly starts coming up in physics, as you can see. I'll show you in a sec. We'll do a physics kind of question in a second.
Do you mean that specifically only for 90, or?
If you can't get like the square root of 64, square root of 81, square root of 16, like something that's exact, don't start rounding things. This is basically my gist. So if you square root 90, you're going to get some number with a bunch of decimals after it, right? You'll see. We do this question down here, you carry, like, if you round, that's what we call rounding error. So like, let's suppose we have like a 3 or 4 step question where I have to find x. Like, this is a typical physics question. You have to find x, you take x, you plug it into another equation, you get a number, and then you solve for something else. If you round in step 1, that's what we call rounding error. That is going to, here we go, percolate into some of your final answer, that error. It's just going to carry.
So you mean like round at the very end?
Round at if you're ever going to round anything, ever, you round at the very, very end. Which, in terms of physics, most of the time when I try to like tutor it or teach it, like I push kids to not type numbers into their calculator, ever. You solve it algebraically with the variables and plug the stuff that you know in at the very end. Then there's no rounding ever. You do not want to round. It creates error. Okay? Where you can't. So that's what I'm saying. That's what I'm saying, like when you go to, like if you went to Waterloo Math, there's a way to deal with this in an exact way. Okay, which you'll do next year. But that's what I mean. Like, you don't necessarily need a calculator. You don't need to know the square root of 90. You will be given the tools to work with the square root of 90. And I guess big picture for you guys is I'm okay with what I'm about to write here as a final answer. Okay, x is equal to 5 plus or minus the root 90. I'm okay with that. So you could say x equals 5 plus root 90, and x equals 5 minus root 90.
So like on the test, you wouldn't want to start.
I wouldn't give you a question like that on the test. I would give you, this is fine. If I'm going to ask you a question about this, I'm going to say, here's the quadratic, here's the equation, graph it for me. The fact that I have a root 90 in there does not tell me anything extra about your ability to do this process relative to something that works out nice. I'm trying to test you on whether or not you can come up with two nice x numbers and then eventually plot them and produce the graph. I don't want you to have to plot like these, whatever that is, these decimal numbers, right? Why? You think you're wrong. It's more work for me. If you round, it's wrong. You know what I mean? I'll give you nice questions that work out. So you get two nice x values, you plot them. Right? That make sense? I show you this because when I give you some, you might see in some of the quadratic equation questions that they leave it as root 90, right? As the answers. So you just don't freak out. You're like, I don't have the right number or something, right? That's all I show it to you for. In theory, I suppose if somebody else were to ask you, Retta, if somebody else were to ask you to plot this parabola, like if you did it in a harder course or something, then yes, you'd plug it in and you'd get 5 plus some number that's a decimal or something, you know what I mean? And then get x equals this and x equals that and plot it. Okay. But I think I've gotten you through the hard part. Okay. I'm okay with that for now, because anybody can type the square root of 90 into their calculator. I don't want to stress you with that. Okay. You want to do D? Then we're almost done, okay? So, I'm going to take the 10, move it over. I get -2. I'll do this one a little quicker. I'll do the next couple. Okay, it's the same thing over and over again. Can throw some wrenches in there and like make you question what your answers are, but that's about it, right? Like if I gave you a question where you square root the negative number, you might go, oh, what does this mean? Have I done something wrong? I can do that. I'm not going to do it every time though. So if you end up getting a negative number on the left side, you end up trying to square root a negative number, check it. Either if it is genuinely like right, then leave it alone. But chances are, if you've done it 2 or 3 times on a test where you're getting a negative number under the square root, I'm not going to ask it that many times, right? That make sense? That's testing the same concept 3 or 4 or 5 times. Like, just be careful. It's easy to, the sign errors can come out here and then they create issues. So just be a little bit careful with moving things from one side to the other. Okay? So, there are your 2 answers there. Okay? I guess Retta, like when x is just something that equals, it's just x. We haven't, it was like our word problems where we had like things that actually had financial meaning, like word problems. Right? Then we would actually solve. So we'll do that in the last question here. But I think even this last question will work. So 5x squared, I'm going to do this one before we do the word problem, equals 30. Is everybody okay with that? Divide both sides by 5. Okay. Do one more to actually provide context, and if we need to, we'll solve the square root piece because it'll mean something this time. Okay? So when you're dealing with physics, does it make sense to ever have a negative time? Doesn't make any sense. But there are all sorts of instances in math where you get answers that satisfy the equations, but they don't necessarily mean anything in real life. Does that make sense? With these ones, you're going to get one answer, and this goes with physics too. You're going to get one answer that like is negative. Negative time doesn't mean any sense or make any sense. But then the positive one will be your actual answer. That's the one that contextually means something, right? So, this question, the following equation represents a path of a baseball where h is the height in meters and t is the time in seconds. Okay? Like that parabola I drew over there. It was outside on the street and I threw the ball. So it's basically just like this, right? Determine when the ball reaches the height of 11 meters. I guess I'm changing it a little bit. It's telling you, or it's asking you to determine when the ball reaches a height of 11 meters. Where's the height in the equation? On the left side. Okay, I can solve for any height I want. I could say I'm going to plug in when was the ball at 15 meters. Well, for this one, it's just asking me for 11, so I'm going to plug 11 in for h. Now, one more little layer for you. Let me ask you a question. I'm thinking off the top of my head here, okay? This thing represents the path of a baseball, right? What if I asked you, at what time did the ball reach 200 meters in the air? Does anybody have any contextual idea of how high 200 meters is? Very high. Does it even make any logical sense that the baseball reached 200 meters high? So, in terms of mathematics, what do you think is going to happen to the equation?
You would just substitute h for 200.
Yes, but after that, like as soon as you go to solve for t, what's going to happen in your head as you do the workings? My guess is you're gonna end up taking the square root of a negative number, and it's gonna mean that there's no time value that satisfies that, right? There's no time value that satisfies the ball reaching 200 meters because it conceptually does not make any sense for the ball to reach 200 meters. So you get a negative underneath your square root. Does that make sense? There are no roots that satisfy the fact or the height when the ball reaches 200 meters. It's just not a point. Does that make sense? Just trying to provide like a little bit more layering for the negative underneath the square root, because it doesn't mean anything. It's just not an answer, right? There's no solutions. Okay, so we can solve this question like normal. Okay, I'm gonna subtract the 36 from both sides. So we get 11 minus 36 equals negative t minus 5 squared. What's 11 minus 6? 36? Negative 40. Oh, you're right, sorry. Negative 25 is equal to negative t minus 5 squared. Divide both sides by negative 1, because there's a negative out front. So I get 25 is equal to t minus 5 squared. Right? I can square root both sides to deal with the squared, but I have to write the plus minus when I do that. And so I get plus minus root, plus minus what? Square root of 25 is 5 is equal to t minus 5. Okay. Then I add 5 to both sides. I go 5 plus minus 5 is equal to t. So I get 5 plus 5 equals t. 5 minus 5 equals t. So t equals 10. T equals 0.
Wait, so why did we minus it by 1 again?
We divided by 1.
Divided by
Negative.
1.
Because there's a negative 1 out front.
Oh,
So you just gotta get rid of it. Yeah, that's all. You're just gonna divide both sides by -1 to get it to cancel. Yeah, Coco.
Well, now you have two values for t.
Yeah.
Which one do you put in?
They're both true.
Well, which one are you gonna use?
You say, that's a good question. We didn't finish actually. Therefore, the ball reaches a height of 11 meters at t equals 0 and t equals 10.
How does that make sense?
Oh, good question. Good question. I was hoping somebody's going to ask because I was excited you were going to ask. What does it mean? It means somebody is standing on the top of a building, right? That is 11 meters tall. They throw the ball. It goes up. It reaches a maximum height. It doesn't go away forever, right? What happens? Remember what where the 11-meter line is. It doesn't stop. Like the ground's down here, right? The ball's going to go up and come back down to the ground. What happens to the second half? It goes up, and then it comes down again. Can we see that? Here, I'll try to fit it nicer. Ball gets thrown when time equals 0. Somebody starts a stopwatch. The way it goes, but they're throwing it from like up here on the second floor or third floor, right? Then it goes. Doesn't take off forever. It's got to come back down. It crosses the path of 11 meters horizontally 10 seconds later. Yeah, right.
See, the thing that confused me is even though the question doesn't specify, I just immediately assumed that the 11-meter mark was the vertex. I don't know why I assumed that. So I thought that there would only be like one actual point that works. You know how you're saying that there's one that works and one that doesn't?
Yes.
So I thought there would just be one.
There are times where like you let me think here for a sec. There are times where the parabola extends into the negative portion of the graph and then you get a negative time. There are a little bit more like specific questions.
Isn't that like, if it goes into like the negative,
Yeah.
wouldn't that be like, oh, the swimmer dove into the water? How deep?
That's for distance, not necessarily time.
Oh.
That's for like a height. So a swimmer dove into the water, yeah, the height gets negative, but the time still keeps going on. So it doesn't make sense to have negative time, but there are questions where like you use the quadratic equation for a physics question, and the quadratic equation spits out a negative time value. That doesn't mean anything.
It's just a solution for that.
It's a solution that satisfies the equation, but it doesn't mean anything in the context of your physics question, where time cannot be negative. Does that make sense? It's just something to be aware of. So when you guys take grade 11 physics, the assumption is that you've done this course. And then the math that you do in physics cannot exceed what you've done in this course. Does that make sense? So you're going to see like quadratic equation, you're going to see factoring, you're going to see substitution, elimination to solve for things. It cannot exceed that because you don't know anything else. Then you take the 3U math, right? Your 12U physics should stem off of your 3U math. You can never do more physics, or the amount of physics you can do is limited by the amount of math that you've done. in my experience. So in university, every physics course I took in university, I had to take a math with it, for like a pair. And I had the same number of each. That make sense? That's just a little tidbit extra for you, okay? I'll give you the questions here. You guys can practice. You take a picture of that, Coco, yeah?